Number one here, relying on some definitions. Some quantitative data sets do not have medians. So quantitative data is quantities, numbers. And whenever we have numbers, we can always arrange them in order from smallest to largest and find the one in the middle, which is the median. So all quantitative data sets do have medians. Number two, we're trying to match this scenario, find the graph that would match with the scenario, and it's the distribution of scores on a 50-point test where a few students score much lower than the majority of the students, and that's the key thing we're going to be looking for. And so with the distribution on the x-axis, you have the different possible values that can occur, and the height of the bar tells you how many people are getting each of these different values. So B is our correct solution because most of the people are scoring over here. We can see because these bars are higher. But then there's a tail to the left because there's a few people scoring a lot lower than the majority of the bulk of the people. Just to look at some of the other scenarios, pull up graph C here. This would be like everyone scoring pretty much the same. It's spread out evenly over the entire range of scores. This would be a few people scoring much higher than the bulk, because here's the bulk of the data. Most of the people are in these lower end, and then there's a few trailing out to the higher numbers. And then this last example would be a pretty symmetric or even spread, where the bulk of the data is in the middle, and then you have a few less people scoring above it and a few less people scoring below it. So B is the correct answer, but also look at the x-axis. This is a 50-point test. And so B is actually the only x-axis that makes sense, where people are scoring anywhere from 0 up to 50. The values on these other x-axes don't even make sense for a 50-point test. For number 3, we have our data here, and we're going to find the mean, median, and the mode. And right at the beginning of section 2.3 is when it talks about mean, median, and mode. Mean is another word for the average. Median is the value that's exactly in the middle. And mode is the one that occurs the most often. And there are formulas. You can work these out by hand, but I want to encourage everyone to use technology. So I'm Control-C to copy, and then I'm going to come over to Excel. And in Excel, Control-V to paste my data. So the mean, you would want to add up all the data values and divide by how many there are. Or in Excel, you can type equals average, open your parentheses, select the data, close the parentheses. In Excel, we'll add them all up and divide by how many there are to get the mean. The median, you need to arrange them in order from smallest to largest, and then find the one that is in the middle. And if there's an even number, then you would average the two in the middle. Or equals median, open parentheses, select the data, close the parentheses, and it will return the data value, the median, for your data set. And so those values, make sure you round to the correct number of decimal places by entering the mean. Mean, median, and mode are measures of the center of the data. So the mean represents the center. It's one way to try to represent or measure the middle, the center of the data. The median, enter in that value, and again, it is a measure of the center of the data. And the mode would be the value that occurs the most often, and they all just occur one time. There's no repetition, so there's no value that occurs more than the other, so there is no mode. Number 4 is about finding a weighted mean, and rather than just add up all the data values and divide by how many there are, you have to add up all the data and their weights. You multiply the data value by what weight it has, and that's the sum of all those on top, and then divide by all the weights on the bottom. This little symbol here means to sum. So sum up all the weights for the bottom and sum each data value multiplied by its weight on top. And here's the information about our weights. A's are worth 4 points, B's worth 3 points, C's 2, and D's 1. So those are the data values we could have. And they're weighted by how many credits the class is worth. A 3-credit-hour class carries more weight than a 1-credit-hour class, and so on. So in the top part of our weighted average, we want to take each data value and multiply it by its weight. So our data values are our grades. A B counted for 3 points, so we have 2 of those. It says we have a B in 2 different classes, and the weight of those Bs is 3 credits, 3 credit hours. And so we're going to want to multiply those. So in Excel, you can do cell reference C2, and I want to multiply that by D2, value the B multiplied by the credit hours. And the reason it's nice to do cell reference is that Excel is smart. I can just drag that down, and here it's doing C3 times D3. Okay, so I've done my B's. I have an A, which is weighted with 4, and A is a value of 4. I'm getting those just from the problem here, A4, B3, C2, and D1. And A is a value of 4, and the weight of that is a 4 credit hour class. So 4 times 4 is going to be 16, and that's what we get for our multiplication. So we got a D, which is worth just 1 point in a 2 credit hour class, and a C in a 3 credit hour class, and the C's are worth 2, and it's a 3 credit hour class. All right, so there I've done all my different values, my 2 B's, my A, my D, and my C, and the different weights they have. You multiply those together, and then you sum those up for the top part of your formula here for a weighted average. Now, equals sum, open parentheses. I'm going to just grab those with my mouse, close the parentheses, and it sums up. The top part's 42. And what we divide by on bottom is the sum of all the weights. So equals sum, open parentheses. I'm going to grab the weights. We're just adding up all those values. And so 15 on top, or 42 on top and 15 on bottom is what my weighted average is going to be. So 42 divided by 15 comes out to a 2.8 is going to be the mean grade when weights are taken into consideration. 4 credit hour classes are worth more than 3 credit, worth more than 2 credit, and so on. For number 5, we have a frequency distribution, and we're going to find the mean for that frequency distribution. And the formula here is discussed in section 2.3. We're going to divide on bottom by how many data values there are, and on top, we have to look at each class separately. And for each class, X is going to be the midpoint of that class, and F is how many data values are in that class. We multiply those together for each class, and that symbol, again, means add up all those results together. Do that on top, and then divide by how many data values there are to get our mean or our average for the frequency distribution. So coming over here, I'm going to copy it to the clipboard, Control-C, and come into Excel, Control-V to paste it. And all the steps are shown here. What we need to do, we need to find that midpoint of each class first, so then we can multiply it by the frequency for that class. And so I'm going to make a little column here called midpoint. It's the lower and upper limit added together. We're basically finding the one exactly in the middle. So you would take the lower and upper limits added together and divide by 2. That'll give you the value that's exactly in between those two. And then we want 34 and 37 added together. And we want to divide that by 2. And so on. We want 38 plus 41 divided by 2. I got to make sure I put that in parentheses so it divides the sum by 2 and not just that second number by 2. And 42 plus 45, add those upper and lower class limits together, divide by 2, and now you have the 4 midpoints. So you take each midpoint and multiply by how many data values are in that particular class. And just do that drag formula in Excel, and it is dragging that same formula down where it's taking the midpoint for each class and multiplied by the number of data values in that class. So you add all those together, sum all those up. And that's the top part, and the bottom part is the total frequency of all the data that we have. So add the frequencies for all the classes together. The total amount of data was 27. And so we want to do that division there to get our final answer. 954.5. We're dividing it by 27 for our solution. And when you enter your answer, make sure you round to the correct number of decimal places that are indicated. And to talk quickly about why we're using this formula, when we want to find an average, we would want to add up all the data values and divide by how many there are. And think about what we just did. We ended up dividing by how many there are. We added up the frequency and divided by that value. But we can't actually add up the data values with the frequency distribution because we do not know what the data values are. All we know is how many of them fall within a certain range. So because we can't add up the actual data values, we have to just estimate what they would be. And so we know that, for example, there's 11 in this first class, and we're going to use the midpoint as the estimate for all 11 of those. Some of those data values are probably above the midpoint, some are below, some are close to it, but using the midpoint captures that balance, and we use the midpoint multiplied by 11 because there's 11 data values in that class, and we do that for each of the classes and then divide by how many there are, and that's the best way to estimate the average for that data when we just have a frequency distribution. Number 6, we're into section 2.4, asking about standard deviation and variance. The reason we use standard deviation more frequently is because it is in the same units as our data. And you can check these out in section 2.4. It's in the same units as the data, whereas the variance is in those units squared, which is a meaningless unit. So we'd rather use the standard deviation, which is in the same units as our data. Number 7, asking about the range of the data. And we're going to find the range of the data in this graph here. And right at the start of 2.4, it talks about the range. It's one of the ways we measure how much the data varies, how much variation there is in the numbers. And we do it by doing the maximum data entry and subtract the smallest value, the minimum data entry. And so this example chart is showing a woman's age at first childbirth. And our smallest data entry is 24, and then we had 2 of those in our data set. And then we had 5, 25, and so on. The height of the bar is showing how many there are at each different age level. And our oldest lady was 34. So the range 34 minus 24 would give us a range of 10 for our data. Number 8, asking about the range again. Here we have a dot plot, and each piece of data gets its own dot. So our largest, our maximum value is here at 96.78 at 98. And our smallest data value is at 74. 98 minus 74 gives us a range of 24. Number 9 is again asking about range. So we need to identify the maximum and minimum values here. And I'm going to show how to do that in Excel. Copy it with Control-C. Pasting it into Excel here with Control-V. Now you can do equals max, open parentheses, select the data, close parentheses, and it finds the maximum data value for you. Now with just 10 values, you could probably do that by sight, pretty easy. Equals min for the minimum. But if you had a super large data set with hundreds and hundreds of data values, it's much easier to use max and min here. So here we have our largest and smallest. We want to do subtraction here. So equals D1 minus D2 to take the max minus the min, and we get our range of our data set. The problem wants us to change one of the data values and see what the new range will be. So we're changing 46.3. So changing our max here, we're changing it to 55.3. And the nice thing about having the formulas in Excel is the max is going to update automatically. And then our subtraction, it's still written in there, so it updates and we get our new range of 31.5.